Hello class, I'm back. This is Mr. McAllen, and I'm going to be giving a quick refresher video for arithmetic sequences and series. And now we left off talking about just a plain old sequence and series, and now we're going to focus on more specific instances of what a sequence and series is for the arithmetic case. For example, we're going to do that first, then we're going to talk about finding the sum of an arithmetic sequence of an arithmetic series, and then we're going to solve some typical problems. So, getting right into it, an arithmetic series is one where if you look at the terms of the sequence, they all increase by the same amount. For instance, 3, 6, 9, 12, 15, 18, so on. They're all increasing by what we call a common difference. And in this case, the common difference we denote as D is equal to 3. Now sometimes we could have a sequence that goes down. So 18, 15, 12, 9, so on. The common difference value here would equal negative 3. So a positive D value means you're going up in value, a negative D value means you're going down. So in this lesson we learned that there is a general term expression for the amount at any value n, and that equation says that you need to know the first term in the sequence, and what you're going to do is you're going to add it to the number of terms minus 1, because this will be the number of differences times the difference value. Let's see if that works. Let's see if it holds up to the test. We'll try to figure out the next term right here. That would be 1, 2, 3, 4, 5, 6, the seventh term. Let's see if we can figure that out. So a to the 7 would equal the first term plus 7 minus 1 times 3. Let me plug in the value for the first term, and that was 3 plus, this is now a 6 value times 3. So what we're doing for the seventh term is we're adding 3 to 18, and we should get 21. And that's kind of what I expected that next term to be. So the formula for finding the amount at any value n seems to be working well, and you can only use this. Let me work on my spelling here. If you have an arithmetic sequence. Again, an arithmetic sequence is when each term varies by the same common difference. Okay, so now let's look at finding the sum. So I talked to the class about this detention that it's a legendary story. Who knows if it's really 100% factually true or not. But Gauss, who many consider to be the father of this type of math, was assigned a detention, and the teacher basically said, you can go home once you sum up the numbers, the natural numbers from 1 to 100. And within minutes, Gauss, came up with the answer, and probably less than minutes because he was a genius. And he gave the teacher the answer, and then I don't think the teacher really knew what the answer was, so had to end up actually figuring it out on their own, as the story has been told so many times and probably changed over the years. But the basic idea was what Gauss saw when he was trying to add up the natural numbers was that instead of adding them in a sequential or a serial fashion, he looked at the numbers in terms of the first and the last, there being a pattern between them. And this is what we base our summation of a series on, of an arithmetic series, is if you look at the outermost terms, the first and the last, they add up to 101. And then you have 50 pairings of the 101 sum, because we have 100 natural numbers that we're adding up. And when he did this, he got 5,050 for the total amount and finish the problem in a matter of seconds instead of it taking a whole afternoon. So we have a summation formula for any, trying to generalize that formula. If we add the first and the last, and we multiply that by the number of terms divided by 2, we have the general sum formula for an arithmetic sequence. So we have two formulas that we are going to use in this section that will be helpful to us. We have the amount equation, and we have our summation equation. In many equations that we get, they ask for the sum, but they've left out a detail. They've either left out the end value, or they've left out the last term. And what you need to do is you need to solve for that by using the first formula. And once you get either the end value or the final term in this series, you can find the summation of the entire series. So let's do an example problem with that. As you can see, I wrote up a problem, and so if we want to find the sum of the first 30 terms of this series, we need to know what the 30th term is. We have to fill in the blanks for this equation. We want to find the sum of the first 30 terms. We have the first, we need the last, and we're going to multiply it by n over 2. And we know what n is. So we just need to figure out the last term. So the 30th term is equal to, as it says up in our first equation here, the first one plus the number of terms minus 1 times our d value. I'll just plug in those values, and that will be 3 plus 29 times 3, and the a to the 30 would be 3 plus 87, or 90. So now you take that result and you plug that in for a to the 30 into the sum equation. So our first was equal to 3, our last was equal to 90. We're going to multiply that by 30 divided by 2, and we should get our answer. You just need to probably use a calculator, so that would be 93 times 15. And the sum of all these numbers would be 1,395. Let's look at one other example. We have if we plant flowers in a trapezoidal shape, and one base has 20 plants and the other base has 6 plants, and there are 2 less in every row, what is the total number of plants we must purchase? So at first look, I just want to jump right on in and use the summation equation, and I'm going to write down the sum of all the plants is going to be equal to my first row plus my last row, all multiplied by the number of rows divided by 2. Only problem is when I start plugging in the values, my first row has 20, my last row has 6, and I look to see what I don't know how many rows I have, so I need to figure out the n value to use this equation. So that's where I go back to my amount equation. The amount is equal to the first row plus n minus 1 times the difference value. And I know my amount in the last row was 20. In the last row, sorry, it was 6. In the first row, I had 20. And I don't know the number of rows, but I know the difference value was 2. Make sure you put in -2 for this. And now when you solve, you would subtract 20 first. And you would get -14 is equal to n minus 1 times negative 2. You would then divide the negative 2 from both sides, and you would have 7 equals n minus 1, and then n equals 8. So that has to be the number of rows. So we take that value and we put it back into this equation. We're going to sum up 8 rows, 26 total for the first and the last, and we're going to multiply that by 8 over 2, and the sum of the 8 rows will be 26 multiplied by 4, which would be 104 plants. I hope this has helped refresh your memory on how to solve some of these problems, and I look forward to doing this again for the next lesson. Take care.